Ahoy hoy, Mr. Nickerson here, and we're here today to talk to you a little bit about solving systems of equations by substitution. If you can, please pull out the packet you got in class, and we'll get started. Alright, so let's take a look at example 1. We'll go through the steps as we go through the example, so have your notes out ready so you can see everything that's going on. Alright, for substitution, what we need to do is we first need to solve one of the equations for one of the variables. And it says there, choose the easiest one. What that means is you don't want to make it more work on yourself, and you frankly want to make it happen as quick as possible. For our first example, you can see that one of the equations is already solved for. Y equals 2x minus 3 is already solved for. So it would be foolish for us to go any further and solve anything else. So step 1, this time, was already completed. Step 2, to substitute into the other equation. What the other equation means is the equation you didn't move or touch. So that's x plus 3y equals 5. My big hint is that you put a parenthesis around what you're going to do substitution with. Wherever we see y, we're going to replace it with 2x minus 3. We're going to substitute it, hence why it's called substitution. So we'll rewrite it, x plus 3 times that parenthesis. Then from there, we just continue and we solve for x, using skills that you learned from in pre-algebra and Algebra 1 Part 1. We'll distribute. Be careful of the signs. And then we'll combine like terms on our left side and then simply solve. 7x minus 9. 7x and the 9. Both sides. It equals 14. Divide by 7. And we get x equals 2. Remember, just like in the solving systems of equations by graphing, it's an ordered pair answer. So since we found x equals 2, we have the x coordinate. Now, we substitute that x in and find y. We can choose either equation, but this equation is already solved for y, so that equation will be easier to use. So we'll go over here, y equals 2 times 2 minus 3. 2 times 2, 4, minus 3. So y equals 1. Alright, and now what we got to do, we got to finish up this last part by doing our old check. Checking both equations. So we start off, 1 equals 2 times 2 minus 3. 1 equals 4 minus 3. 1 does equal 1. Check our other equation, make sure it works in both. 2 plus 3 times 1 equals 5. 2 plus 3 equals 5. 5 equals 5. Checks out as well, and you have successfully completed your first substitution problem. Alright, let's take a look at example 2. Example 2, same directions obviously. We're still doing substitution, but this time, not one of the variables to solve for, unlike in example 1. Our first step is we need to solve one of those equations for one of the variables. But you need to think to yourself, I want to choose the easiest one. And what that means is you want to choose the letter, x or y, in one of the equations, that when you solve it, it makes it the easiest to plug in, and it makes it the easiest to solve. The hint about solving for the easiest one is you want to look for variables with 1 or negative 1 as the coefficient. Since they have 1 or negative 1 as the coefficient, then you would not have to worry about having fractions. I know some of you enjoy fractions, well, not many of you, but it makes it easier not dealing with fractions throughout. So if we look, we've got x plus 5y equals negative 3, 3x minus 2y equals 8. The best choice probably to solve for on this one would be the x, since it has a 1 in front. I know you're saying, Mr. Nickerson, just took part 1. We just got told solve for y, solve for y, solve for y. That is true when you're graphing. Obviously solving for x when you're graphing is not going to help you out very much. But in substitution, it doesn't matter which one you solve for, x or y. So if we solve for x, we got to get it alone. We'll move the 5y over by subtraction. Let me erase that from my notes. And now, this is no different than the previous problem. We're ready to go to step 2. We're ready to substitute. On the substitution step, I like to put the parenthesis around what I'm going to substitute. And wherever I see x in that other equation, I'm going to plug in that parenthesis. So 3 times negative 5y minus 3 minus 2y equals 8. Now from here, we're going through the next step. We need to solve for y using those Algebra 1 Part 1 pre-algebra skills. We'll distribute. Rewrite everything else. Combine our like terms. Negative 15y, negative 2y on the same side. So we're keeping the sign. Negative 17y minus 9 equals 8. We can add 9 and get negative 17y equals 17. When we divide, we know we get y equals negative 1. Right, our ordered pair. Negative 1's our y coordinate. We need to find x. We could plug it into any of the equations up there, first two originals, or the one we rewrote. Probably your best choice is the one we rewrote because x is already isolated. I'll do that up over here in the top right. So x equals negative 5 times negative 1 minus 3. Careful of your signs. Positive 5 minus 3. And x equals 2. Now that we have our answer, don't forget, we're checking that finally at the end. So if we check, I'm going to write my ordered pair above it. 2 plus 5 times negative 1 is negative 3. 2 minus 5 equals negative 3. That checks. And I'm going to check one more here. 3 times 2 minus 2 times negative 1 equals 8. 6 negative and negative, positive. And sure enough, it checks out. All right, let's talk about example 3. Hopefully you had time after going over the first two to take a look and try number 3. On 3, you first want to choose the easiest variable, which, as you can see, I pointed to with the arrow, is y. Negative y is the easiest variable on this one because it's got the negative 1 in front. We won't have to deal with fractions. Had you chose any other variable to solve for, you'd have fractions throughout your whole problem, and that would make it a much more difficult problem. So, you solve for the equation for y. After solving, you should come up with y equals negative 5x minus 12. Be careful with your negatives. Don't forget about the negative on the y. Once you have that, I put that in the parenthesis, and then I came over here, and I touched the other equation I haven't used. Plug it in, and as you can see going down, combined in our like terms, and got x equals negative 2. After finding the x, you got to find your other variable. Use whichever equation you like. I always use the isolated one, so I went right here with y equals negative 5x minus 2. Minus 12, came up with negative 2, and finally, as you can see here on the left, my checks. All right, and for the final example, example 4, we'll go through it real quick. First off, choosing your best variable to solve for, probably going to be that x. X minus 2y equals negative 3. And after that, you get x equals 2y plus 3. Bring that over here, plug it into your equations, and once you solve that out, you'll get y is equal to negative 1. Finishing with them, from there, find your x value, which is positive 1, and don't forget to check it at the end. We'll see you tomorrow in class. Bon voyage.